Hello, Patriots. Welcome back. This is Mr. Love, a.k.a. the Math Patriot, bringing you another fun and exciting lesson in the wonderful wide world of high school geometry. All right, let's move on to some triangle things. I apologize. It's been a couple weeks since I uploaded stuff. I know y'all missed me. All right, vocabulary. So, first off, a perpendicular bisector. Now, we know the word bisector means what? Cut it in half. So, basically, yeah, I just cut JK in half. So, JR is congruent to RK. Perpendicular means it is they intersect at 90 degrees, at right angles. So remember that when I say a bisector, I don't mean that JK and RS bisect each other. I mean that RS cuts JK in half. I have no information about RS, the lengths of RS, anything like that, okay? All I know is that JR equals RK, and all the angles here at point R are all 90 degrees. Make sense? All right. Now let's talk about the perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So if I know that AD is congruent to DB and that these guys are right angles, then any point I draw on the bisector, on DC, will force these two lines or line segments to be congruent. See, I could put a point right here, and then those guys would be congruent. Any point on there will essentially form an isosceles triangle. Does that make sense? Okay. We've also got the converse of that. If a point is equidistant from the endpoints of a segment, then it has to be on the perpendicular bisector. Now, the way this one's drawn, it can be kind of hard to see it, but basically, if I've got a point, and we'll call this ZY, and I have another point that is equidistant, and this equals this, then that means that this new point, let's call that new point X, that new point X must be on the perpendicular bisector. I know that that one must be perpendicular, and those two are equal to each other. Okay? So if and only if, biconditional, they both prove each other. Make sense? All right. So, let's find the measure of segment FM. Notice I am not told anything about this triangle other than the fact that K is the midpoint of GM and that angle FKM is a right angle. So, doesn't it make sense then that FK is the perpendicular bisector of GM? Therefore, what do I know about GF and FM? They're congruent, therefore it's an isosceles triangle, and FM equals 2.8. Yay.
Yay.
Is that hard?
No.
Good. All right. BD is a perpendicular bisector of AC. Well, I mean, we don't need the word perpendicular here. We just need bisector. So I know that CD equals DA. Therefore, 5x minus 6 equals 3x plus 8. Now what? Solve it. How?
Add 6 to 3x plus 8.
Add 6 to both sides gives me 5x equals 3x plus 14. Subtract 3x gives me 2x equals 14. Divide by 2 gives me x equals 7. And it says find x, so I am done. Yeah, don't pull that. That's a meme. Don't do that. Find x. There it is. Okay, questions? SQ is the perpendicular bisector of segment PR. Find both x and PQ. So, SQ is a perpendicular bisector. Therefore, we know that point Q is the same distance from P and R, so those guys equal each other. So I got 3x plus 1 equals 5x minus 3. Let's see, subtract 3x gives me 2x. Add 3 gives me 4. Therefore, x equals 2. There's one answer. Second answer is PQ equals, well, 3 times 2 plus 1. And yeah, y'all are right. It is 7. Let's actually make that look like a Q. I don't even know. It was some sort of scratch thing, but I would love to say that it was a graphical anomaly because of the tablet and pen, but no, I just wrote it wrong. All right. Concurrent. Concurrent lines are 3 or more lines that intersect at a common point. Okay, so 2 intersecting lines are not concurrent lines. 3 intersecting lines or more are. And that point at which they hit is the point of concurrency. So, P is the point of concurrency between lines A, B, and C. Does that make sense?
Yes.
All right, y'all ready to jump off the deep end?
Yes.
No? Too bad. All right. No, it's not that bad. The circumcenter. The circumcenter is the point of concurrency of the perpendicular bisectors of a triangle. So notice that here, DP is the perpendicular bisector of AB, EP is the perpendicular bisector of EC, and so on. The point that they meet right here at point P is the circumcenter. Make sense? All right. Here's what you need to know about the circumcenter. Perpendicular bisectors of a triangle intersect at a point called the circumcenter. Just restate the definition. That is equidistant from the vertices of the triangle. Which means that here, point P, the distance from P to A is the same distance as P to B, is the same distance from P to C. Okay? Circumcenter is equidistant from the vertices. Make sense? All right. Now, here's the interesting thing about circumcenters. They don't have to be inside. For an acute triangle, yes, they will always end up inside the triangle. For an obtuse triangle, what's going to end up happening is that these guys get forced this direction. And no, you don't have this picture on your notes. But it actually ends up being the back side of this one, the one that comes off the longest side, that intersects with the other two, and the circumcenter is outside the triangle on an obtuse. For a right triangle, they're going to end up on the triangle, or on the hypotenuse. Okay? So circumcenter does not always have to be on the inside. Okay? So, point P is the circumcenter. List any segments that are congruent to each one below. Now be careful because it's easy for students to assume that this triangle is equilateral or isosceles. Don't take the bait on that, okay? Just, we're going to do it for a generic scaling here. So MY. MY is this line segment. What has got to be congruent to MY?
YE.
Why YE?
Because there's a right, it's 90 degrees right there, so it's, what did you call it?
Concurrent, okay.
Lines.
You're dancing all around the actual issue. The circumcenter is the intersection of what? Not the vertices. Go on, what's the definition? Look back at your notes. What's the circumcenter say? That's concurrent lines. What is the circumcenter? Where is it? How do we generate it? The intersection of the perpendicular bisectors. So, if P is the circumcenter, then all 3 of the lines coming out of it are perpendicular bisectors, which means that point Y is the midpoint of ME. So, MY has got to be congruent to ME. Because point Y is a midpoint.
So you mean YE?
Yeah.
Thank you. Thank you. I meant YE. Sir.
Would KR also be?
Would KR also be the same thing as MY? Only if this is an isosceles triangle, which we don't know for sure. All right. I'm going to jump back to part B in a second. We'll come back to it. All right, ER. What's got to be congruent to ER? RK, by the exact same logic.
That's KP.
What?
That's KP.
I said it right. I wrote it in the wrong spot. Okay, how about MN? Yep, exact same logic as before. It'd help if I could actually say and write the same things. NK. For me, it does. That's why I was doing that. Okay. Now, KP. Here's the problem, though. KP is not drawn.
What?
Because KP goes from point P to point K. This line here, this segment is not KP. KP is actually, let's see if I can get this guy on there.
Nice.
So KP is actually there. So KP is the line segment that goes from the circumcenter to a vertex. So what other line segments would have to be congruent to that? By the way, they're not drawn either. Well, PE is drawn, yeah, okay, PE. As well as MP, yes, because those are the other distances from the circumcenter to the vertex, or to the vertices. Okay. Sorry, any questions?
No.
Well, in this particular case, it wasn't drawn. That's not always going to be the case. All right. A triangular-shaped garden is shown. Can a fountain be placed at the circumcenter and still be inside the garden?
No.
Right, because it's obtuse. So if I draw my circumcenter, it's going to end up being like this. And there's my circumcenter. So the answer is no, because it's an obtuse triangle. And what's the only time that the circumcenter is inside the triangle? In a acute triangle. Where is it in a right triangle? On the hypotenuse. Okay, angle bisector. By the way, what was an angle bisector? Cuts. It's a ray or segment that cuts an angle in half. Okay, so a point on the bisector. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Now, remember that when we have a line and a point, how do we find the distance between a point and a line?
Measure it.
But where? Where would I measure it? Because here's the thing. The point is a definite location, but the line, I could draw it anywhere. I mean, I could measure that distance. Would that be right? No. Would I do that distance? And forget the scale. I mean, would I measure this distance? Come on, guys, y'all know this. You always measure perpendicular to the... Because this isn't level. Come on. Give me a break. I swiped a line across. There is 1 degree off. Remember, we always assume the stuff I draw is perfect. Okay. Okay. So, it's equidistant from the sides of the line, meaning that here FD and FE are congruent. Okay? Also, the converse is true. If a point on the interior of an angle is equidistant from the sides of the angle, which, I mean, pay attention to what's going on there. It says that I've got a point on the interior, and that point is equidistant, then that means that it must lie on the bisector. Okay, so equidistances imply bisectors. Bisector implies equidistances. It's a biconditional, it goes both directions. Okay? Any questions on that one? All right, so find the measure of segment DB.
5.
Why is it 5?
Because they're equal. DB is
Why are they equal?
BD and DC are equal.
Because
Because
the
of
angle bisector.
Okay, angle bisector implies that these distances are the same, so yes, that equals 5. Guys, by the way, the reason I'm making y'all step through this logic with baby steps is because you're going to have to use this type of logic when you do proofs.
I thought you were done with that.
Okay, find the measure of angle WYZ. WYZ, I look at it and I see I got an angle. Point W is equidistant from point X and point Z, which means that WY, by the converse of the angle bisector theorem, must lie on the converse, lie on the bisector. Therefore, these two angles are congruent, and WYZ is also 28 degrees. All right. Moving on. QS. Find QS. I see a angle bisector.
Yes, you do.
Therefore, QS equals RS. So 4x minus 1 equals. So subtract 3x gives me x. Add 1 gives me 3. And I'm done? No. What do I do? So QS equals 4 times 3 minus 1. 12 minus 1 is 11. Done. All right, questions?
No.
Okay, we talked about circumcenters. Now we're talking about incenters. The incenter is when you take the point of concurrency of the angle bisectors of a triangle. Notice this is different than the circumcenter. Circumcenter was the segment bisectors, well, segment perpendicular bisectors, whereas the incenter is the angle bisectors. Sorry, I lost my word there for a second. Angle bisectors. Okay? Any questions about how to form that?
No.
All right. Nice little property here. The incenter is equidistant from the sides. So here, point P is my incenter because it was formed by bisector of C, bisector of A, bisector of B, and therefore these three are congruent. PF is congruent to PE, is congruent to PD. Now at first that looks very similar to the other picture we've drawn until you realize that, notice that AE right here definitely is not the same length as EC. So point E is not a midpoint of AC. Okay? So basically whenever I have the angle bisectors that intersect, that point of concurrency is equidistant from the sides. When I have the perpendicular bisectors that intersect, that point is equidistant from the angles. Okay? So those two work very similarly. By the way, there is a single case, or there is a case when the incenter and the circumcenter are in the same place, and that's at an equilateral triangle. Okay? Okay. And we'll also talk about another one next class period called the orthocenter. Yeah. Okay. Find ST if S is the incenter. Now, it tells me that S is the incenter, which means that, and realize, guys, this isn't exactly drawn to scale, that TS is congruent to SU is congruent to SR. So, if I can find the measure of any one of those, then I know the measure of all three. And I'm looking at triangle SUP is a right triangle. So I could say, let's label this one A, a squared plus 8 squared equals 10 squared. Do the Pythagorean theorem on it to get a. So that gives me a squared plus 64 equals 100. A squared equals 36, therefore a equals 6. Which means all of those are 6. This is 6, that's 6, that's 6. So ST equals 6. What part of that confused you? So the important part here is that we are no longer doing problems that have one step of logic in them and then we're done. We've got to take multiple steps here. We're going to first off see in-center because it tells us in-center implies segments are congruent. Then I got to look at it and say, which one of those three can I find? Well, I'm looking at SU. I see a right triangle, which means Pythagorean theorem. And then I filter all the way, do the work, and filter myself back to ST equals 6. Okay, you got to do multiple stages of logic to get from one or from what you have to the answer. All right, angle SPU. Find SPU if S is the in-center. All right, in-center tells me that these guys are congruent. What else does it tell me? Okay, yes, it's a right triangle. But how do I form the in-center?
Oh, congruent angle? No, the bisector
angle,
of angles.
Yes, the bisector of the angles. So I know that angle TNS is congruent to angle SNU. I also know that TMS is congruent to SMR. And I know that UPS is congruent to SRP. So in particular, how much is TNS? What's the measure of it?
56.
Well,
Wait,
TNS.
Oh, 28.
This is 28. What about the measure of TMS?
31.
31 degrees. And then these two I don't know, but I could put an X there, right? If it's a full triangle, yeah, because MMP is a full triangle, so I know about the sum of all those angles. Come on, guys. Sum of angles in a triangle is 180. So I have 28 plus 28 plus 31 plus 31 plus 2x equals 180. And then we just solve. 28 plus 28 plus 31 plus 31. Let's see, that's 56 plus 62. Comes out to 118 plus 2x equals 180. Therefore, 2x equals 180 minus 118 is 62. Dividing by 2 gives me x equals 31. So, SPU, is 31 degrees. Measure of angle SPU equals 31 degrees. Yeah. All right, I believe 11 is the last one. Okay, find the measure of GF if D is the in-center. Remember, in-center tells me that segments are congruent. Angles are congruent. And those three are equal. So if I want the measure of GF, actually, I don't even need to do the in-center on this one. GF is just this one. We call that point B. It's just a Pythagorean theorem. Turning in A. 5 squared plus B squared equals 13 squared. 5 squared is 25 plus B squared equals, anybody know it? 169, close.
Nice.
Subtract those, 169 minus 125 is 144. Square root of that gives me B equals 12. So GF equals 12. All right, that's all for now. We'll come on next time and we'll work on a few other things in triangles, specifically orthocenters. And as always, stay patriotic.